Welcome to the SAFECode e-learning course, Security Development Lifecycle. The goal of this course is to provide you with essential information about the Security Development Cycle, or SDL. You will learn about the process of SDL, its practices, and how to apply them to your development method. By learning about SDL, you will be able to improve your own development methods in order to better integrate security aspects with the goal of built-in security. The primary audience for this course is software developers as well as software development leads. Other parties involved in the process of software development will benefit from it as well. Having an understanding of the SDL process, its concepts and practices will improve your understanding of security and privacy within software development. For this course, it is assumed that you already have knowledge in software development methods. In the first section of the training, we cover the basic idea behind SDL and what is needed to incorporate it. Next, we take a tour through the MS SDL, which is an exemplary SDL we will use as reference. This tour includes security and privacy principles, the MS SDL process with its phases, and a how-to on merging SDL into an agile development method. We also created an example scenario for you, which we will rely on to give you a practical example at each process phase. In the last section, we want to give you a quick overview of additional models that can help you in defining an SDL that is right for your environment. Let's begin this lesson with a definition and explanation of the idea behind SDL. The term SDL is not standardized, and therefore you will find a variety of alternative names for it. Some examples are Secure Software Lifecycle, Secure Software Development Lifecycle, Security Development Lifecycle, and Security Assurance Program. In this course, we are going to expand the term SDL into Security Development Lifecycle. Most SDL fall into the following categories: a maturity model, a process model, or a software development process itself. Each approach has its own advantages and challenges, but what they all have in common is that they aim to support developers in building more secure software and thereby reduce the cost of development in the long run. Let's continue with a closer look at the goals and areas on which a secure development lifecycle can have an impact. The primary goal of an SDL is to reduce potential security risks and privacy issues while trying to improve the quality of a software product in these two areas. In the long run, this will reduce development costs due to the fact that issue mitigation will be moved up to earlier stages of the lifecycle. Furthermore, there will be a reduction in production code issues, which will improve customer satisfaction. Another positive effect is the improvement of the technical competence of developers with regards to security, considering they will spend more time on the matter. Sounds like a good thing to pursue, right? On the next slide, we are going to explore reasons why security is still not an integral part of development. Many cybersecurity threats and attacks are based on vulnerabilities and design weaknesses in software products. Even today, only a limited number of products are actually designed with security in mind. This is not the fault of the programmers per se. Why? Because security awareness for software developers is not part of every developer training. In many cases, security is not given enough importance to receive enough dedicated resources at the right time. Another reason is that possible threats are often underestimated or unnoticed until it's too late, due to the fact that no threat modeling was performed at an early stage of development. Threat modeling is an important task within an SDL process and identifies, enumerates, and prioritizes risks based on the view of an attacker. A well-defined threat model serves as a solid baseline and helps to determine potential security design issues and assists in the verification of the product. That again brings us to another common problem, where software has been released and customers demand a fast fix for a severe vulnerability. Many developer teams don't have a vulnerability response plan because of lack of security knowledge. Quite often, you will find the notion of considering security solely as a feature. It should rather be seen as an integral element of development with strong ties to quality management. With this flawed approach, you may end up having a significant number of critical vulnerabilities in your product. This may damage trust into the software product, subsequently leading to brand damage for your company. To prevent and in order to be prepared for such security problems, a strong SDL is a proven solution. But what are these typical requirements for SDL to ensure the increased security of the developed software? The answer is to have the right set of knowledge available, as well as policies and procedures integrated into the existing development process. It is essential to keep up with SDL practices from the very beginning of development until the end of life of the product. Aside from being a continuous process, people are assigned responsibilities and roles for security. This helps to build up deep security know-how as security experts emerge within your organization. Please note that not everyone has to become a full-fledged security expert. For many people, it is sufficient to have a basic level of security knowledge and training related to their actual field of work. Another necessary element are guidelines. Guidelines should be created and applied for various topics which provide assistance and guidance for developers to make qualified decisions. A great example is concrete secure coding guidelines for specific platforms, languages, and topics. If you look at all these elements, it becomes obvious that in order to make an SDL work, dedicated resources are needed initially, but it will definitely pay off in the long run. If security becomes an integral part of your ongoing development process, your software quality will improve overall. You don't have to invent everything again on your own. Today, you can rely on a broad selection of guidelines from different sources to pick from. A typical characteristic of an SDL is that it isn't a one-time effort, but rather a continuous process that is improved over time. Every SDL consists of multiple phases which map mostly to the classic software development process. Typical phases like requirements, engineering, design, implementation, verification, and maintenance are essential parts of an SDL, but it could also contain additional phases. Furthermore, it is possible to map a modern SDL to an agile development method due to its flexibility. Implementing all practices of an SDL at once from scratch can be a bit too much to bear for your organization. In order to develop over time, many SDLs contain some form of maturity model to reach defined levels of security. They aid an organization in building up its security capabilities level by level. And last, it should be noted that the SDL model may not cover all security practices in detail, and additional measures may come from outside sources. Each aspect of development will have to be supplemented with additional resources such as the OWASP Top 10 for web developers. Now, let us look at the most well-known example of SDL, the Microsoft Security Development Lifecycle. The crucial elements of the SDL are security and privacy principles that assist you in determining where and which security and privacy measures are needed. How these principles can be integrated into your development process and which possible measures result from them will be covered later on. Let's focus on the principles first. The security principles are often referred to as SD3 plus C, which stands for Secure by Design, Secure by Default, Secure in Development, and finally, the Communication Principle. The same structure can be found in the privacy principles, which are referred to as PD3 plus C. Over the span of the next slides, we will give a short summary of these principles, but will highlight only some of them in order to give you a better idea on what is required. It should be noted that none of these principles can stand alone, and all principles are equally important. The principle of Secure by Design is first on our list and states that software should be designed with security in mind. This should begin with the architectural design of the software and include creating threat models, subsequent threat mitigation, as well as a process for the elimination of application-specific security vulnerabilities. The effect of the Secure by Design principle will lead to an improvement of software security at design and implementation steps. The Secure by Default principle enforces established security concepts and principles. It states that the default configuration should be as secure as possible because it will be the actual field configuration for many systems. To further elaborate on this principle, we will show you some examples on how this can be achieved in practice. Let's start with a very essential security concept: the principle of least privilege, which tries to limit the permissions of a component in order to be able to run with a bare minimum of permissions. For an application with access to a database, this could mean restricting access to the schemas or tables needed and further limiting the allowed access types. The next concept is defense in depth, which states that the components should not rely on a single threat mitigation. If a security control has been circumvented, there will be other layers in place that provide protection. That's why the assets of the application should be protected by multiple layers. In a web application environment, this could mean the hardening of the database, but at the same time implementing a defense against SQL injections. By implementing these multiple layers, you have a chance to limit the impact of an attack and increase probability of breach detection. Another important security concept is the reduction of the attack surface by applying limited default settings, for example, through disabling unused services. Similar to this is the avoidance of risky changes that an application applies, for example, to the host during installation. A common violation of these principles are games or even professional applications that open firewall ports without informing the user. Next up is the security in development principle, which covers the definition of deployment guidelines for defining how to securely deploy each feature of a program. It is followed by the need for analysis and management tools to determine and configure the optimal security level for a software release. Ideally, additional tools for patch deployments should be provided as well. The last principle in our list is the C in SD3+C, the communications principle. It states how to respond to security issues and declares the need to engage with users to answer questions related to security issues. By doing this, you will increase the feedback received on your development and gain insight into which concerns users might have. We now come to the principle regarding privacy. First in line is the principle of privacy by design, affirming that software should respect the privacy of the user. Therefore, the user needs to be provided with a notice which data will be used in what way. Additionally, the user has to give his consent about the suggested kind of data usage. To assist with this, user policies and controls should give the user a mechanism to manage privacy settings. Even when the user agrees to let your application collect sensitive data, the application should only collect the actual data needed and use it in a form that bears in mind the privacy of the user. Also, remember to define how to store and transfer the data in a way which respects security and privacy concerns. This will mostly lead to measures like encryption, restricting access to data, and ensuring that actual usage of the data complies with use cases communicated to the user. Another privacy principle is privacy by default, which means that software should be shipped with conservative default settings. An example would be to only enable privacy-related settings such as automatic contact data transfer after the user has explicitly requested it. Privacy in deployments declares that privacy mechanisms should be documented for administrators and users. An example would be a detailed definition of where privacy-relevant data is stored so it can be handled accordingly. The communication principle finally includes the publication of privacy statements. It should also promote transparency. And ideally, you also have a privacy response team, which is dedicated to handling privacy issues. Now that we have an understanding of the underlying principles, it is time to take a look at the SDL process itself. Furthermore, we will talk about the different approaches to development and how to integrate the SDL in classical and agile development models. Let us start with a short overview of the SDL process, whereby this is a simplified view that we will later expand on to clarify the phases required. As you can see, the process is based on classical development methods and follows a flow from design to release. Depending on your development method, this process may differ for your implementation. As a precondition, developers should receive appropriate training before the actual development project is being tackled. Naturally, the earlier the training is done, the larger the positive effect on the project's security outcome will be, as developers will have additional knowledge at their disposal. Such a training should not only include the very basics, but also updates about recent security and privacy trends. To account for new threats and to keep up to date, it should be done at least annually. Additional training should be tailored to the field of work of each developer as needed. This includes secure design, threat modeling, secure coding, security testing, and privacy-related topics. If time and resources allow more training, it is recommended to explore more advanced topics. This could be, for example, security response processes or implementing custom threat mitigations for your product. Now that we have talked about the SDL process, we can take a look at how this process can be adopted to an agile method. After this section, we return to the process for an in-depth view of the phases. The MS-SDL is an example for an SDL which has been designed for heavy-weighted and waterfall-like development methods, which doesn't include agile methods. To match the requirements of a short release cycle, the process has been adapted and the result is called SDL Agile. Instead of following a fixed order of steps, tasks are defined that are mapped into the agile development process. This means that you don't have to repeat every phase in a sprint, but only a certain set. A good example is the design phase, where establishing requirements is done only once and threat modeling is done per sprint. This helps to adapt the to-dos and aspects of SDL to the way of agile development. Although SDL Agile was designed for short release cycles, it still takes a certain amount of time to complete all requirements. In projects with very short release cycles, such as 2 or 3 weeks, the team can temporarily skip certain SDL requirements and provide the best trade-off between security, features, and duration of release cycles. As we mentioned before, requirements have certain practices, defining if they should be repeated multiple times or just once. To make this easier, SDL splits the requirements into 3 categories. The first ones are the every sprint categories, and like the name implies, these are never skipped. Requirements that are found in this category must be met to fulfill essential security goals, and software should never be released without these requirements being met. Otherwise, the sprint is not complete. Next on the list are bucket requirements that bundle tasks that should be performed on a regular basis over the lifetime of the project, but are not considered critical for every sprint. There are 3 possible buckets: one that bundles verification tasks, one for design review tasks, and one for planning tasks. Instead of fulfilling all of them, at least one SDL requirement from each bucket should be done each sprint. Please note that this doesn't mean that some requirements can be completely ignored, as every requirement addresses some form of security or privacy issue. The last category is the one-time requirements that are generally once per project tasks. Most of these tasks should be easy and quick to complete. Even though these tasks are short, there may be many of them and a team might be overburdened with the combinations of every sprint and one-time tasks. To address this issue, the SDL Agile defines a grace period to complete each one-time requirement. The time window depends on size and complexity of the requirement and can range from 1 month to 1 year. On this slide, we present a more in-depth view on the MS-SDL process. Feel free to pause the training to look at this diagram longer. You can see that the phases of the process are very similar to those you can find within a classic development process, which is not a coincidence as we noted before. The next slides will cover the typical phases of the process like requirements, design, implementation, verification, and release. The process ends with an incident or vulnerability response plan for handling privacy and security issues. The following theory slides are heavily based on the official and publicly available documentation of the MS-SDL in version 5.2. As we have already heard, security and privacy need to be considered essential elements during the initial planning stages. Here, the team can already identify corresponding security and privacy requirements that are needed in addition to common software requirements. To achieve this, security experts need to be appointed, a minimum security and privacy level for the software must be defined, and a security item tracking system has to be set up. The minimum security level is commonly defined in bug bars and checked at defined quality gates. A bug bar is a defined threshold which describes the maximum acceptable severity of vulnerabilities. The bug bar is only set once and should never be relaxed. The bar will also be used for checks before a release, and the gate will not be passed until all known vulnerabilities with a defined rating are resolved. Another important part of the requirement phase is the cost analysis, which helps to understand the costs and requirements in handling privacy risks. For privacy concerns, there is an initial assessment where we determine the project's privacy impact rating and can estimate the amount of work that needs to be done to comply with the chosen privacy requirements. To ensure a common understanding, a guideline for these privacy ratings should be established and checked. To help you understand how these phases are implemented, we will show you an exemplary process for our virtual premium cat video exchange portal, CatTube, where our engineer Michael has been tasked with integrating security with the development. When starting off with their secure development lifecycle project, Michael and his team performed a re-evaluation of their existing privacy and security setup. What they found was that due to the nature of the data collected on their site, they had an additional legal obligation to keep records of all financial transactions for 5 years. Each additional obligation was then added into the lifecycle by creating tickets that reflected the updated requirements. The design sets the foundation for later phases and establishes best practices to follow during the project. Here you can add security features to functional specifications and ensure, for example, that only secure functions and robust cryptographic APIs are used. Threat modeling is also part of the design and is a critical activity to identify security risks. You cannot build secure software unless you understand what its actual assets and risks are and how to reduce the latter. Without a decent threat model, the design phase can and should not be concluded. All projects and code that are exposed and all code written by or licensed from a third party should be considered within the threat modeling scope. This includes new projects, features, and functionality, as well as legacy code. Microsoft developed the free SDL threat modeling tool that can assist you with the creation and management of threat models. We now return to Michael, who has created a threat model for his web portal and found several threats this way. In a post-mortem of an attack from last year, it was found that certain management functions use client-side authentication, which allowed attackers to gain privileged access to the back-end servers. Using these elevated rights, the attacker was able to deploy a network sniffer on the production network and could listen in on the network communication occurring between servers. To remedy these two weaknesses, secure server-to-server communication and server-side authentication were made mandatory design principles. Now we head further down the development process and start with the implementation of our product. Before you start writing your code, you should consider and follow best practices of actual secure development specific to each technology, platform, or language. A specific example for web applications is to set the HTTP-only flag for cookies. Or for a C# application, you should avoid using the link execute query. And you should never use deprecated unsafe functions, such as those mentioned in SAFECode's secure memory handling in C. Another helpful element during implementation is static code analysis. Measures and best practices like these should be adhered to during the project lifecycle. As always, see what fits your environment and adopt appropriate coding techniques and methodologies. Planning and scheduling of user documentation should also be done at the appropriate point in time, when functional requirements are stable enough. Delivering decent documentation is as important as delivering the program itself. When reviewing their codebase, it became obvious to Michael that some common best practices had not been followed in concern with their primarily used coding language. One example was the use of self-designed database queries, where prepared statements were recommended. This led to possible SQL injections. As a fix to these problems, it was decided to replace all the queries with prepared statements and create a test framework that would allow the progress of the query update to be verified. After the implementation follows verification. The primary goal of the verification phase is testing for privacy and security violations. The necessary tasks can be separated into 3 categories. First, we have the dynamic analysis where the product is being searched for vulnerabilities at runtime. Typical tasks could be to look for memory corruptions, like buffer overflows, privilege issues, and other security problems. This can be done by tools, and if a continuous integration or continuous delivery system is in place, you can integrate security-related activities into your tool chains and thereby reach a higher degree of automation. Fuzz testing describes the task of feeding your product with random or malformed data, and with this, you can discover issues that lead to program failure. With the right tools, a high degree of automation can be reached, and only modest effort is needed. The last category of practices describes the review of the attack surface. This helps to ensure that any changes to the product have been reviewed and tested for possible security and privacy issues. A task to undertake is a security push, which is a team-wide focus on threat model updates, code review, testing, and documentation review, or in other words, according to Microsoft, bring risky code up to date in a short amount of time relative to the project duration. It is an effort to uncover changes that might have occurred during development with an impact on security or privacy. Please note that a security push is only one measure and it is not sufficient on its own to bring security into the project. As preparation for a security push, you need to allocate time and resources and define criteria to determine when the push is complete. A criterion could, for example, be if all bugs with a high rating are fixed. Also, don't forget to train the team before the push starts. The duration of the security push depends in general on how much time you have already invested into security and privacy and how much code needs to be reviewed. If you already brought all legacy code up to current security standards, you will need less time for the push. In agile development, a minimized version of security push is done with a spike. A spike in this context is a short side project with the aim of finding as many bugs as possible. During a spike, all related analysis tools should be run against the project and all found bugs should be logged. A typical task could be a review of the code with the assistance of a static code analyzer. Some exemplary tools are the RATS tool, which supports various languages, the FindBugs tool for Java, or MS-FXCOP for C#. These are only some examples of free tools, and there is a vast number of commercial alternatives that can be used. Another useful activity would be to integrate tools that check for credentials left in your code, or you could even test builds with fuzzing automatically. If you use Team Foundation Server or Jenkins, you will find a lot of helpful resources on how to achieve integration on the web. In our virtual portal CatTube, the testing framework that was established in P3 was extended to include fuzz testing. The result thereof was the discovery of certain query parameters which could hang the application backend, leading to a DOS attack. Furthermore, during an attack surface review, Michael's team found that the web server used in their production environment had some demo projects enabled by default, and these projects had the possibility to upload code and execute it. In the release phase, the product is ready for public consumption, and the team is also ready to handle requests from the users. The core concept of this final stage, from a security perspective, is the creation of an incident and vulnerability response plan, which is a defined set of procedures if any security or privacy issues should be discovered after the release, either by external or internal parties. Even after all verification has been done, the software can still contain bugs, of course. In order to handle these bugs, a predefined response plan has to be in place. This plan commonly contains certain scenarios and how to react to them appropriately, including the flow of communication. The product, however, cannot be released without the appropriate final security review, also known as FSR. Such a review can last from a few days up to several weeks and is done by the security team together with help from the product team. A decent FSR can take time, especially if serious issues are found during the review, so don't forget to allocate enough time for the review. The rough idea behind the FSR process can be explained in these steps. First of all, work has to be finished on all open security and privacy issues. The next step is the review of the threat models and any deferred security-relevant issues. The process continues by validating the results generated by security tools being used. Finally, one should ensure that everything has been done to remove vulnerabilities that surpass a certain threshold. If for some reason SDL requirements can't be met, an exception request has to be submitted. The outcome of the FSR is quite simple. Either the product passed or not. If the first case is true, then the product has met all SDL requirements or has passed with some exceptions. These exceptions should be logged and addressed in the next release. The second case may require an escalation if requirements cannot be met and the security advisor and product team cannot reach an acceptable agreement. The team can either correct the SDL requirements or escalate to higher management for decision. After passing the FSR on their application after the first round of the lifecycle, the last step was the implementation of signed application packages. Unfortunately, the first iteration caused incorrectly signed packages leading to an error on deployment. During the deployment of the signed packages to the staging environment, surprisingly, some unauthorized packages were found. The investigation of these packages was handed over to the incident management team. To summarize, you can see a short list of improvements that may be the result of implementing an SDL. Even after the program has been published, the SDL requires security responses. This is exactly what is done in the post-SDL phase. It includes response to privacy and security issues as well as reaction to user concerns and giving the user the possibility to give feedback on privacy and security. A further step would be to create a community where developers help users with their problems. Be aware that even when all security-related requirements have been addressed, it may be possible for an attacker to circumvent security measures through new means and thereby undermine product security. In this section, we finally give a quick overview of which additional resources you can rely on when implementing your SDL. Always keep in mind that most SDL occurrences, including the MS SDL, are only a collection of best practices. You should always try to find a solution that suits your individual needs, which could mean to combine measures from multiple SDLs. There is a variety of sources for guidance related to SDL, and the following 4 are the most well-known and popular ones. The first one is the MS SDL, which made up the main part of this training. The next one is IEC 62443 4.1, which is part of the industrial standard IEC 62443. Why this standard could be interesting for you will be covered later on. Open SAMM is an open framework developed by multiple vendors, which is no longer actively maintained but mentioned here as it is the foundation for the next 2 models. OWASP SAMM is the direct successor to the Open SAMM framework. Finally, BSIMM is based on Open SAMM but is a closed framework, which represents how other companies actually implement and maintain their SDL. As we have already explored MS SDL thoroughly, we'll spend the rest of this course with a brief look at the other SDL candidates. OWASP SAMM stands for Software Assurance Maturity Model as maintained by the Open Web Application Security Project, OWASP. It is a vendor-independent and open framework based on studies and analyses of the development of software products. It is a maturity model which consists of 3 different maturity levels. The SDL is separated into 4 business functions. Each of these functions have 3 security activities that group together similar strategies and activities. The higher the maturity level is, the more things obviously have to be done. BSIMM is a maturity model based on OpenSAMM, and therefore the structure is similar to its ancestor, but still includes some significant differences. The primary difference is that the domains, also known as business functions in OpenSAMM, and security activities are different. BSIMM relies on the BSIMM study, which collects and evaluates security activities from more than 100 organizations across different sectors. The BSIMM is kind of a practice collection and can be a useful source for security activities in the sense of being a benchmark of effective practices. Development of software with security in mind is even more important in areas like industrial automation and control systems where loss of life and environmental damage is a realistic threat. For this purpose, Part 4.1 of the IEC 62443 is dedicated to requirements and implementation of an SDL. It is based on a maturity model and includes 4 consecutive levels. The primary goal of the standard is to provide a framework to address a secure by design and defense in-depth approach within the development process. To achieve this, the standard defines 5 groups of requirements, such as security by design, secure implementation, and requirements for security management to ensure that security-related activities are adequately planned, documented, and executed. The IEC 62443 4.1 is the only SDL model that can be verified by a formal certification process. Even if you are not planning on getting certified, the standard is still a very comprehensive guide and another valuable collection for requirements regarding secure software development. We reached the end of this training, so let's briefly sum up what we have covered. We looked at the basic concepts of SDL and discussed why it is important to integrate an SDL to your development process. We also learned what an SDL could look like based on MS-SDL and which elements are commonly contained. Also, remember that most SDLs are not strictly defined and are rather a best practice than a standardized rule. The SDL should fit your requirements for security and privacy, and therefore you should take a closer look on the different models before tailoring your own approach. If you're looking for an effective way of teaching your development organization to sustainably build secure software, SDL is the most reasonable approach to follow. Finally, we have prepared a list of links and resources which we have used to create this training that might help you to further increase your understanding of SDL, as well as the different alternate candidates to MS-SDL. Thank you for taking this SAFECode training course.